Alrighty, guys, we're going to add again to our notebook a little bit more about points, lines, and planes, but now kind of what happens when we have more than one of them and they start crisscrossing each other. So in our table of contents, underneath points, lines, and planes, this went from 1 to 3. And so, oh my gosh, did I not number? Oh, I numbered this. Sorry, I'm looking at last year's. On page 4 and 5, we are going to talk about things that intersect or cross each other, so intersecting. And then we're going to talk about some words that maybe you heard before, coplanar and collinear. Or maybe you can kind of guess what they mean by their prefixes. Okay, so 4 and 5, collinear, coplanar, and intersecting stuff. Okay, so if we turn to that page, hopefully we have our points, lines, and planes all set. And we're going to add page 4 and page 5. And we will need the next 2 pages from our packet that we got at textbook handout. So the next one should look like this. And if I turn that over, looks like that. We're going to fold that in half, right like a book. And then you can see that top box we're going to cut out and throw away. Now, we're not going to fully cut out the whole thing. We don't want to lose this. It's just that top part. You're going to cut out that rectangle. Just the top rectangle. And you don't need that. And then if you want to be super cute, you can cut out doors again. It's up to you. So we have little doors. And that is going to go on page 4. Lost my tape. And then the next page that we should have in our packet looks like this. It says coplanar, non-coplanar, collinear, non-collinear. We're going to flip that one over as well. And we're going to fold that in kind of like the points, lines, and planes one, where we want to have these doors meet in the middle. And then if we want to cut along the dashed line to kind of have actual doors, open each one. And then however that makes sense to you, like there's really no good way for me to print this one. It's stupid. You can tape that way or that way. I'm going to go, I feel like that makes more sense for me. Tape that in there. Glue that in there. Okay. So points, lines, and planes are kind of funky on their own, but then when I start, just because they're hard to define, they're super simple concepts, but sometimes simple concepts are the most difficult to like fully explain and understand because we just kind of know them. So when I start getting more than one of these things, then really interesting stuff happens. So, I want to highlight it. Do I have one? Oh, I don't. Sorry, I'll underline. So if I have 2 lines, something that could happen is they cross each other. And when 2 lines do cross each other, they always cross at a point. Okay, so if we open that up, we can see what I mean. If we have 2 lines intersecting or touching each other, they will only intersect ever at a single point. So for example, if I was looking at a slightly more intricate picture here, we have our line LN, we have a line PK. So name the intersection of line LM, we could also call it that, love it, and PM, we could also call it that because M is also on that. Now, because there are 2 lines, it will always cross at a point, and the point that these 2 lines are touching on is M. The way we name a point is just with a letter, uppercase letter. So that's it. There she is. Ooh. Okay. Next, if I have, I just flipped that. I missed it. If I have 2 planes, so imagine 2 pieces of paper, and if they start crossing each other, or another type of plane is maybe a wall. If I have 2 walls touching each other, you kind of get the corner of the wall, like when you're a kid, go stand in the corner or whatever. And a corner isn't a point, it's a whole line. So when I have two planes intersecting, they intersect at a line. Always, always a line. Okay, and it's kind of hard to draw planes. Sometimes we draw them as like these crazy quadrilateral things. And when you see that little dot, 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 that's trying to show you that something is behind. So kind of this plane right here, let me outline. This plane right here. Now you can't see that line going behind. Maybe they should have done the dot, dot, dot back there too, but they're showing you that this is behind that purple plane. And two planes will always intersect at a line. That whole corner that you had to stand in when you were in trouble is a line. So for example, if I'm looking at a slightly more complicated picture, we have our plane A that's kind of flat here, and we have our plane D kind of going up and down like that. And I can see that this is sort of behind, like that's on plane A. And I can call them that because they're cursive. So I should have used cursive letters there. Oops. Name the intersection of plane D and plane A. Now, because it's two planes crossing, I know my answer has to be a line. And so I have to look for the line that is touching both planes. Now, I only see two lines. I see this line here, YS, and I see this line here, XZ. And that is the one that is on both, because YS, it kind of goes through A, or it kind of goes through D, but not all of D. It just like touches through D at R. This is going all along where those two planes are meeting each other. So they are crossing at line XZ. Now I could also call that line XR or RZ. It doesn't have to be the endpoints. It just has to be any of the points on the line. Okay, and then last on here, if I have a plane and then a line. So imagine you have a flat piece of paper and then like your pencil is the line going through it. Now it could layer it on top of it, but if they're intersecting each other, then they are only touching each other at one spot. So we have a point again. I want a different color, not purple. So this intersects at a point as well. Okay, so if I have a plane and a line that isn't like lying flat on the plane, then they will intersect at a point. So if I have this crazy three-dimensional shape over here, where again, these dot, dot, dots are kind of going back into the page, they're behind. Name the intersection of the plane HEF. Again, they have to name with 3 letters. Although if I kind of connect those 3 letters, it's weird, right? It feels like it's not talking about the whole plane, but it is only talking about one plane, and that's the top. So definitely talking about the top here. It couldn't be any other plane. It can't be the front because this goes behind. It can't be that side because we got the front, so it's got to be the top. And then if we look at line GC right here, those two things touch each other only in one spot, and that's at G. So point G, we call a point with an uppercase letter, so G. Now, if I would have been really tricky and said, name the intersection of plane HEF, so that top still, and line BC, those would not intersect because, like, he's not touching the top, he's only the bottom. That would be something that is skew. So something that's not touching and not really parallel and on different planes is skew. Okay, so we also want to talk about, so that's kind of our intersecting stuff. On the next page here, what it means to be collinear, non-collinear, coplanar, and non-coplanar. Now, hopefully it makes sense. Whatever this is, that is not. Like non means not that. And I don't know if this is obvious or not, but I always like to dissect my words kind of like I did with the non, like non means not that. But linear, I know is a line. And to be co with something, co with anything, planar is plain. Co means like together, like we're co-parents or cooperating. That means together. So when I say collinear, what I mean by that is multiple points on a line. So points all on the same line. And I can't really just talk about two things here. It has to be, because 2 points will always make a line, it has to be 3 or more. So maybe we'll put in parentheses, gross. 3 plus has to be 3 or more points. So if I had the points A, B, C, D, and then E, I could say that A, B, C, and D are collinear. They are all on that line. So to be non-collinear, you are not on the same line. So not on a line. And using that same example, there's only one point that is non-collinear, and that's E, is non-collinear. And so then hopefully it makes sense and isn't too much of a stretch to understand that coplanar means stuff on the same plane, could be lines or points. So objects on the same plane. And we're going to do an example right up here, so I'm not going to draw. It would be terrible. And then to be non-coplanar would be not on the same plane. And we're going to do examples up here of those. So if we look at that middle, we have a lovely picture to use that I already created. We want to answer the question, are the points F, A, and Y coplanar or not coplanar or non-coplanar? So if I find F, A, and Y, I feel like I already know my answer. F and Y are on the same plane, and they would be because they're 2 points, and 2 points can always be on the same plane. But A is clearly not on that plane, so non-coplanar, and that's because of A. And A is goofing everything up. Okay, next, are F and Y collinear or non-collinear? And I always love this question because it really makes you think about things. So F and Y, looking at a picture, I would say not collinear because they didn't draw a cute little line between them. However, if I have 2 points, I can always draw a line. So I'm going to leave this one up to you. You can write what you want, but you got to explain it. So I'm going to go with collinear because 2 points always make a line. A better question would be something like this one down here. So let's just jump to it. Are the points F, R, and B collinear or non-collinear? Now, if I have 3 points, that's the moment it becomes a question. If I have 2, I can always make a line. If I have 3, then I don't know, are they? Because I can draw a line between F and R, and in fact, they already have. And if that line continues through B, which it does, then it is collinear. If I said F, R, and E, they would not be collinear. So collinear. They are all on line FB. Sorry, I jumped around. If we go back to this one, are the points F, R, and B coplanar or non-coplanar? So again, this one's kind of interesting because they are all on the same line, but B is not really on any of the planes drawn here. So again, this is when you can kind of argue because I could draw a plane wherever, although, ooh, no, not on this because they're a straight line. And I can't draw a plane from 3 points on the line. So this is definitely non-coplanar. The easier reason is because B is not obviously on the plane, it's off the plane, but more so it's because they are collinear, and if you're collinear, you can't be coplanar. So hopefully that kind of makes sense. Okay, try out the Google Forms after this, and hopefully it goes all right.